Hello everyone, welcome to my channel. Today we're going to be looking at the ICE tables, and that's the most important method in my mind that you'll be using in your chemistry class for the equilibrium unit for solving a lot of questions. So this method is very useful and it's definitely very worth to learn. And in this video, I'm going to be using one question example to show you all of the details that you'll be covered in your class for solving this type of questions and the details that you have to be aware when you're doing these questions by yourself. So let's jump into the questions directly. Okay, so read the questions first. It says 1.60 moles of CO, 1.60 moles of H2O water are found in an 8.00 liters container at 690 degrees. Or 690 Celsius. At equilibrium, the concentration of hydrogen gas is 0.15 moles. Okay, so this is the reaction that given to us, and it says to calculate the value of the equilibrium constant. Okay, so for these questions, the first thing you have to be aware is that you have to be identified what type of information that the question given to you. So for these things, it gives you the reactions, the reactants, like the moles and the liters. So which means that you have to calculate the concentrations for this reactants by yourself, because like you cannot directly use the moles and plug that into the reactions, right? You have to calculate the concentrations first. So concentration, remember, is the moles divided by liters. So let's just solve it. So the concentration of CO will be 1.60 moles divided by 8.00 liters, which will given to us 0.2, and there's 3 sigfigs, so it's 0.200 moles. Same thing, let's calculate the H2O concentration for this. 1.60 mole. They're actually the same thing, right? But just to be detailed, like I'll show you all of the steps that will be used. Okay, so we figured out the concentrations for the two reactants. And just to remember that if the question gives you the concentration for the reactant, then it's a forward reaction, which means that the product side has to be positive, right? And if the question gives you the concentration for the products, which means that it's a reverse reaction, and the reactants have to be positive, right? So just remember that whatever the side that gives you is the side that you start with. So let's just starting by plugging all of the things into our reactions. Well, I know like sometimes the peoples will call it rice tables because they will prefer to write the reactions again at the top of the equations just for future like the step solving more easily, and that's also my personally prefer. So I'll just write the reactions again at the top. So then I think it will help me to be more clarified when I'm solving these questions step by step. Okay, so let's start. ICE tables. What does I stands for? Well, it stands for initials. So initials means that whatever the concentrations that the question given to you, you have to just set it up in the first line. So, which means that the concentration for CO, we already figured that out, is 0.200 mole. And H2O, same thing. And they haven't given us the the products, like either of these, the question didn't tell us. So we would just assume that it's 0 moles. Okay, and so for the C stands for changes. So the changes, remember that because this is a forward reaction, which means that we are producing more of the products, so the products has to be positive, and the reactant side, the same thing, has to be negative. So then I will just using the variable x to stand for the quantity of changes amount, because we don't know anything about like what amount they changed, so we'll just use a variable to stand for it. Okay, so the E stands for the equilibrium. So E, I think personally, is the most easiest line, because it's just basically you add the first two lines together, like I plus C, initial plus the amount of changes, will gives you the equilibrium. So we'll just add them together. Okay, and then we just basically finished the setup for the ice tables, and let's just looking at this more quickly for the questions again. So it says the concentration of hydrogen gas is 0.15 moles. Okay, so which means that X, because hydrogen gas is H2 and it's a product, and the equilibrium state that there's only X for it, which means the X has to be 0.15. So whatever the questions that given to you, okay, so whatever it's a reactant or products that given you the amount of like the concentration that already in the equilibrium state, you just directly plug that into the E lines in the ice tables. Okay, so in this question it's more easier. We can just directly put X as a 0.15 moles, which means that CO2 will also be 0.15 moles. And the H2O is 0.2 minus 0.15 mole, so which will be 0.50 mole. Yeah. Okay, so the same thing as for CO. Okay, so then surprisingly, we figured that out that all of the concentrations for the reactants and products at the equilibrium state. So in order to find the equilibrium constant, remember the constant is always the products over reactants. And there's a things that you have to be aware of is that the products, like the products right here will be the CO2 and the H2O, and the reactants will be CO and the H2O. And the good thing about this question is that all of the reactants and products are given to you as gas state, which means that you just have to directly plug that into the equilibrium constant equation, because like the gases, we're counting for that because they have an exact concentration, but that doesn't work for the solid and the liquids. Like if they giving to you a reactants or products as a pure solid or pure liquid state, then you'll not have to plug that into the equilibrium constant. You'll not count for that because they don't have an exact concentration. But in this question, we all have given into the gas state, which means we just directly plug that in. And there's also a nice thing about this question is that like all of the coefficients is 1, which means that we don't have to like raise any powers, because like if the question given to us is a 2 right here, like a 2 CO2, like 2 carbon dioxide, then you have to plug the coefficients in here for the exponents. So remember, the coefficients in front of the either reactants or products will be the corresponding exponents for that reactants or products concentration. Okay, so then this is our general formula for the equilibrium state. Let's plug that into the real numbers. So which means that it will be CO2 0.15 moles. And because like we just times the same thing, so I'll just use the second power just for simplicity. And the CO, the same thing with waters. I would just use the second powers. So then let's just use our calculator, and after we calculate it, we will find it's 9.0. And this is the 2 sig figs. So this is our answer. And remember, the equilibrium constant or the reaction quotient, which will be covered in the later videos, the Q, doesn't have any units. So it's unitless. So which means that 9.0 right here is good enough for this question. Okay, so basically this is everything that you have to be aware of, and everything, every detailed steps that you'll be covered in your class for solving the ice tables questions. And I hope you learned I hope you learned something from this video. And if you like my video, please subscribe and leave some comments below. I would like to hear your thoughts. And I hope you have a nice day, and I'll see you in my next video. Hope you have a great day. Thank you.